Chapter 3, still talking about matter. In section 1, we talked about the properties of matter, physical property and a chemical property. In section 2, we talked about the changes that matter can go through, a physical change or a chemical change. In section 3, we're going to talk about how matter is mixed together. So the objectives for this section: contrast mixtures and substances, classify mixtures as homogeneous or heterogeneous, list and describe several techniques used to separate mixtures, a review vocabulary. Let me see if I can, let me go back here. Review vocabulary. Substance, a form of matter that has a uniform and unchanging composition, also known as a pure substance. We talked about this in section 1. So if you look at these pictures down here, we have tap water and we have distilled water. A substance, a pure substance, has a uniform, unchanging composition. You can see that tap water has more than one colored dot in it. That means that it contains more than one item. So it has salts and it has minerals in it. Distilled water doesn't have any of that. Distilled water would be considered a pure substance. Okay, new vocabulary that we're going to talk about. Mixture, heterogeneous mixture, homogeneous mixture, solution, filtration, distillation, crystallization, sublimation, and chromatography. The main idea for today, the main idea for this section: most everyday matter occurs in mixtures, which is a combination of two or more substances. So when you go out in the world, every day you're going to see a lot of mixtures, but very few substances. Okay, so what is a mixture? A mixture is a compound. Let me go back here. A mixture is a compound of two or more pure substances in which each pure substance retains its individual property. So if you look at these pictures down here, we have a glass of milk and we have some cake batter. Both of those are mixtures. Now, we have two types of mixtures. We have homogeneous mixture and a heterogeneous mixture. A homogeneous mixture is a mixture where the composition is constant throughout. So both of these examples would be homogeneous mixtures. The milk, it is milk all the way through. You can't go in and say, oh, this is a fat particle, this is a water particle. It's all combined together, just like this cake batter. You can't tell where the eggs are and where the sugar are. It's all mixed together. Homogeneous mixture. A homogeneous mixture that is a liquid is called a solution. Okay, so here we have water, but we've added Kool-Aid to it, so that makes it a solution. Sugar water would be another example of a solution. Okay, these two pictures are pictures of heterogeneous mixtures. A heterogeneous mixture is a mixture where the individual substances remain distinct, so you can pick them out. So if you're eating the salad and you don't like tomatoes, you can go pull the tomatoes out. If you don't like the onions, you can pull the onions out. Over here, if you don't like the red M&Ms, you don't have to eat them because you can pick them out. Here are some examples of types of solutions. Okay, so you can have a gas-gas mixture. You can have a gas-liquid mixture. You can have a liquid-gas mixture. You can have a liquid-liquid mixture, a solid-liquid mixture, and a solid-solid mixture. All of those make up different solutions. Okay, you guys have already done this filtration back when we did the very first lab, when you had the sand in the water and you had to separate it out. So filtration is a technique that uses a porous barrier or that filter paper to separate a solid from a liquid in a heterogeneous mixture. Remember, heterogeneous, you can pick the parts out. We can pick the sand away from the water. So you pour the liquid through the filter, okay, then you collect clear liquid. Okay, so that's filtration. Another way is distillation. Distillation is a separation technique for homogeneous mixtures that is based on the differences of the boiling points. So this is how you would make distilled water. You would put tap water in this jar, boil it, it would condense, and you know how how you get the water vapor. It is collected in this condensing tube, and then the clean distilled water is collected in this bottom tube. This is how they make, on moonshiners, this is how they would make the alcohol as well. They would use the distillation process. Crystallization is a separation technique for homogeneous mixtures. Remember, they're all mixed together. Homogeneous mixtures that results in the formation of a pure solid particles from a solution containing the dissolved substance. So if we had sugar water and we wanted to pull out the sugar in the water, we would evaporate off the water and we would have this crystal left, the crystal sugar left. Crystallization. Sublimation. This one's really cool. Sublimation is the process of a solid changing directly into a gas. Okay. So this example right here is dry ice put in water, and it goes from directly dry ice into a gas. Pretty cool. Cool stuff. Okay, chromatography. We are going to be playing with this towards the end of the week or the beginning of next week. Chromatography is a technique that separates the compounds of a mixture on the basis of the tendency of each to travel across the surface. Basically, it's molecular weight. It's going to travel according to how its mass. So, chromatography. Pretty cool. Okay, here is a good diagram to help you kind of understand matter. So, matter can be a solid, liquid, or gas. We talked a little bit about plasma, but we're going to leave that one out for now. So, it can be a solid, a liquid, or a gas. Now, we need to determine if it's a mixture or a pure substance. If we have a pure substance, remember, nothing else is mixed in there. So it has a constant composition. It is either an element or a compound. And those two items we're going to talk about in the next section. Okay, so we can go to mixtures. Okay, variable composition. What type of mixture is it? Is it a heterogeneous where I can pick out the tomatoes from the salad? Or is it a homogeneous where the milk is all, or the cake batter is all mixed together? Okay. Okay. Oops, gave you the answer, which is not a technique for separating a homogeneous mixture. Homogeneous is all mixed together. So if you filtered milk, you would get milk out of the bottom, in the bottom container. Which of the following is a heterogeneous mixture? One where you can pick out the pieces parts. What do you think the answer is? Salad dressing. Good job. And that is the end of section 3.